Hi viewers, we are from Group 8, currently conduct a group assignment of BENT 4823, which is a digital communication system. This assignment is about a frame synchronization using a BPSK signals. In this video, we're going to explain our MATLAB coding and results. This code demonstrates the process of generating a binary phase shift keying signals, adding a carrier and noise, performing a frame synchronization using a peak detection and cross correlation, and plotting relevant signals for analysis. Here's the detailed explanations of the coding. So the first part is about the parameters. Fs is the sampling frequency of the system. Fc, the carrier frequency of the BPSK signal. Frame size, the size of the each frame in samples. The guard interval is the size of the guard interval between the frames and in samples. The threshold value used for frame synchronization. So the second part is about generate the BPSK signal. The random binary data is generated using a randy 0, 1 coordinates, frame size, and 1. The com.bpsk modulator objects is created to modulate the binary data into the BPSK signal. The BPSK signal is obtained by applying the modulator to the binary data, which is a BPSK signal equal to BPSK modulator data. The third part is about the add, carrier, and noise signals. The time vector is generated based on the frame size and sampling frequency. A carrier signal is generated using a carrier signal frequency and a time vector. Gaussian noise is added to the BPSK signal using a noise equal to run n frame size, comma 1 times with 0.1. The received signal is obtained by multiplying the BPSK signal with the carrier signal and adding noise. Received signal equal to BPSK signal times with carrier and noise signals. So the fourth part is about the frame synchronization using a peak detection and cross correlations. The received signal is processed for the frame synchronization using a peak detection. A threshold is set for peak detection, so which is we set for threshold for equal to 0.5. The peaks are detected in received signal by comparing it to the threshold, which is a peaks equal to received signal greater than threshold. The received signal is cross-correlated with the transmitted BPSK signal using a correlation equal to ABS bracket in X core bracket in received signal comma BPSK signal bracket out. The absolute value of the cross correlation is taken to empirize the peak detection. The maximum correlation value and its corresponding index are obtained using a max correlation and a start index equal to max index. Subtract with a length of a received signal. If the maximum correlation value is greater than a threshold, frame synchronization is considered successful. The frame start index is calculated based on the syntax index, frame size, and a guard interval. The frame start equal to start index adding with the frame size adding with guard interval. The frame start index is displayed along with the success message. If the maximum correlation value is below the threshold, the frame synchronization is considered failed and an appropriate message is displayed. So the final part is about plotting. So a figure with a tree subplot is created. The subplot 1 is about a transmitted BPSK signal using a binary data is plotted using a stem data field. For a subplot 2 is a real part of the received signal and a carrier signal are plotted against the time. The third subplot is the cross correlation results correlation over the range of the possible offsets are plotted. A vertical red dashes line. A vertical red dashes line is drawn at the frame start index. The start index to indicate the detected synchronization point. The code provides a complete implementation of the BPSK signal transmission, receptions, frame synchronization using a peak detection and cross correlation, and the visual analysis of the signal is also involved. Then we run the coding. So in command window, it shows that frame synchronization is successful. The frame start index is 69. The function of a workspace is as to generate the waveform of the coding. Okay, so the first waveform is about the transmitted BPSK signal. The second output waveform is about a received signal with a carrier. The third waveform, it shows the peak detection of the frame synchronization. So this part is the highest peak of the frame synchronization. So that's all. Thank you.